Hi, and welcome back to the first video, the part two of this cybersecurity series. So what we're going to talk about first, as far as the first topic in video and lab, is going to be identifying indicators of a network attack. And so part of our exercise that I want to discuss is the domain name system, the DNS. It's responsible for name resolution, right? Without DNS, it would not have been possible to run the internet, really. And it just provides the domain name to the IP address mapping. Then you could actually type a URL and get to the desired website rather than remember the IP address, which is good, right? But there is also different ways where, because it's one of the oldest protocols, it has several vulnerabilities, security flaws. I'm going to talk about the various attack types that can be had on DNS and different ways that can be done. So we're going to further our knowledge of domain hijacking by DNS poisoning, spoofing attacks, and universal resource locator redirection. So those are some of the few. There's other ways as well. But what we're going to do for our first task is just verify the domain reputation. So it defines the health status, right, of the domain of the context of messaging. When a domain is used for like sending messages and over the internet. And then the health is determined by various factors, right? So it is like bounce rate, spam, complaints, and things of that nature. But let's go ahead and get started. So let's open up Microsoft Edge, right? If it opens, right, thank you. Right, so we're gonna go to this website here, palosintelligence.com, right? It's just a reputation. As you can see, reputation lookup for the site. So we're just going to type in one of, if not the most used site in the world, google.com, right? So just checking our browser that we're currently using, make sure we're good, right? That was just a DDoS protection page. All right, so everything pretty much looks like it's fully loaded. So we take a look at the location data, reputation details. It gives us pretty good information as far as the reputation details, right? And owner details, who owns it, which is really Alphabet, who owns Google. The mail servers, the content details, and a few other things, right? So if we scroll down a little bit further to additional information, we're on the IP addresses tab, right? So actually, let me take a look here at the volume history. We can see that there are several very, very extremely minor dips, but for the most part, it's pretty steady, right? We can mouse over any of the dates to show us the email value that we can take a look at as far as Google.com in particular, right? So now that we've taken a look at that, as far as the DNS, we could talk about other types of attacks, right? So more and more services make their presence on the internet. Of course, the attack surface increases, right? So from a simple harmless web browser or critical web server, everything on the internet can be considered unsafe, right? So what we're going to do is talk about different types of attacks that can cause security issues, like a DDoS or a regular DOS, man in the browser, man in the middle, evil twin, MAC cloning or spoofing or anything like that. So we're actually going to perform some MAC flooding using Yersinia. So let's head over to the Kali Linux here. Password, almost forgot it. All right, perfect. So now that we're in, of course, we're going to have an emulator, right? Now, just because I'm posting this on YouTube, I can't actually show this. Otherwise, I'll receive another warning like I did from a previous video. So I'm going to enter in the command and do everything necessary, and I'll explain it, and then we'll be able to continue. So it should be just a second. All right, so I've just done, how can I put this? I just saw some CDP flooding, right, from a window, and I actually used some different launches to make sure that the flooding was available for the CDP table, right? So the flooding was initiated instantly, right? And I looked at different MAC addresses, and of course, naturally, they're all different, right? But I looked at the different ones that were being logged, right? And so I also, after I ran it, I took a look at the information and the data that it was breaking down, and then I ultimately stopped it, of course, and that's why I now have a clear screen. Um, I mentioned it earlier. I'm not going to mention it again. Again, YouTube looks out for stuff like this. So I'm going to be very careful about the words that I use, as well as the actions that are done, which are only used for educational purposes in order to further our education and our knowledge of how different attacks work in cybersecurity, for us to better understand how to better protect and secure um, those networks and web servers and everything else in between, right? So next, we're going to take a look at a SYN flooding attack, right? So uh, let's actually talk about what it is. So it's a type of denial of service attack, right? So it's conducted by an attacker to send a flood of synchronizing packets to a target. So whenever there's a flood of a large number of SYN packets, the target can't respond to. So in responding to these SYN packets, the target system starts consuming all its resources and eventually exhausts them. So as a consequence of running out of system resources, the target becomes non-responsive, or it just hangs out in the open, whatever that looks like for a computer. So in some cases, the target also crashes, and to conduct the SYN flooding, they perform a few steps. So again, these are steps that I'm going to perform, but I will not be recording them, and I'll put everything on the other side. Well, I'll explain somewhat, to very vaguely, as far as what happened on the other side. So it should be just a few moments. All right, so I'm still in the middle of doing everything, but so what I've done, I just entered a command into Kali Linux, and now I'm just going to open up Wireshark so we can do some listening. It lets me type. I guess it's still low. That's fine. Will it load? All right, just going to capture some packets, all right? As soon as this is done loading here, and I'm just going to capture the synchronized packets. Now, this isn't illegal, so YouTube is going to allow me to show this. This is fine, so at least I can show portions of it. I want to just get close to the action as possible as far as what's going on and the application of everything that I'm explaining, without showing anything to the detriment of others, right? Because you never know who could come across the video. Even with my video being unlisted, you remind me later. Even my video being unlisted, YouTube is still going to flag it. So there we go. All right, perfect. So we started capturing some packets. And because of what we're running on Kali Linux, there's going to be a flood of syntax that we should see in a moment. There it is. There it is. We see these here. Perfect. Perfect. So there, and of course on, which is this particular server, right? So now this server, Win10, is actually they're running out of system resources. So may become unresponsive when doing this. So maybe if I try to click, yeah, if I try to click here, it's not the computer, it's the computer bugging out, but not like when I'm trying to do a normal task. It's because of what's going on here, right? So sometimes you can get out of memory error. However, the error, if it does or does not occur, it depends on your system, right? And what's going on as far as resources and applications already running at the time that you start the packet capturing. So you may see other symptoms, you may not, but we're just going to keep pushing forward, right? So I'm going to switch back over to Kali while I'm running that command, and then I'll put you guys on the other side of what I'll be doing there, and I'll explain it as best as I can. All right, perfect. So what I did was I stopped the command that was pinging, right? And I also closed out, as you can see, Wireshark here. So now I'm just going to switch off the Windows firewall. So just going to just naturally head to firewall. There it is. Perfect. Here. I'm going to turn off everything because I need to lower the defenses for what I'm going to do to maximize me being successful at it. All right, so we can do this here. Actually, you know what? Actually, no. Let's see, there's something else I want to turn off too. Actually, let me take a look here. No. Going to turn off the real-time protection. See. Make sure everything is good to go. So let's talk about an ICMP flood attack, right? So like the last attack that we were just talking about, right? There's another type of flood attack called ICMP flooding, right? So it's also a DOS attack, denial of service. Instead of sending synchronized packets, it also sends a flood of ICMP packets to a target system. So I'll get into that. Again, I cannot place this on YouTube, even if the video is unlisted. So I'm going to actively take a look at it. And then I'm also going to try to explain as vaguely as possible everything that I've accomplished during that time as well. So I'll put you on the other side of that here. All right. So now we can actually talk about an ICMP flood attack. So, uh, like like the SYN flood attack, right? There's another type of attack called the ICMP flooding, which is also a denial of service attack. Which is in this type of attack, instead of sending synchronized packets, the attacker sends a flood of ICMP packets to a target system. So I did take a look through it, and I also found that this is typically what it looks like when there could be some sort of flood attack on a network. And I specifically looked through the Ethernet because it's a lot more usage going on than normal. It's usually down here, but as we can see those small dips. So as you can see, it's consistently up here, which means something is going on, right? And I believe I had the capture in process for a few things. And so possibly there are packs being captured right from the target system when usually it normally looks like this, right? And sometimes it's when you could take a scan of the network to see exactly what's going on, to see there is someone in for you to remediate, eradicate, remediate, and all of the rest of the things to reel back carefully from a potential attack. All right, so now we can also talk about the ping of death attack. All right, so using the ping command, a ping of death attack, right? You could send, or it would send packets of a particular size indefinitely to a target system. So while it may not bring down the system specifically, it will impact the performance of the target system. So it can use a DDoS attack on a target system to bring it down, which coincides to what I was just showing as far as the task manager and everything looking the way that it did as far as the Ethernet, right? When something is being pinged to the target system and there's some communication going on, is filling or exfiltrating data, what may have you, it'll look something like that as far as what it looked like in the task manager for. Sometimes the CPU, well, usually the CPU, the memory, Ethernet, in some variation of that, it'll show you some increased network activity. So now we can actually take a look at address resolution protocol poisoning attack. And what it is it's known as ARP spoofing. And in poisoning, what happens is a hacker sends a fake ARP message on a network. So the hacker also links its own MAC address with the IP address of the other system. So the attacker could then receive messages, right, that were intended to be sent to the owner of the IP address. So, however, instead of the owner receiving the messages, the AR spoofing can occur if both parties, the attacker and the victim, have the system in the same broadcast domain. So I'm going to browse through a few things as far as reading through more of what it's like, and then I'll give a breakdown of what I find. So while I'm in the process of reading over everything that I'm taking a look at for art poisoning, just want to take a look at the ARP table on the 110 here. So let's actually click this here. So you know what? Let me just do this. So I do it with this command here, right? Just to check the ARP table, right? So we notice that each has a different MAC address, right? So this actually made sense if there was a potential ARP poisoning attack. All right, so now after doing further research, I'm actually going to run the same command again so we can check the ARP table. Let's see what everything looks like here. All right, so if we notice, let's take a look. If we notice 0.2 and 0.4 have the same physical address. The only way that can be done is there is some type of tampering or manipulation, right? Because every device has a different machine address, right? So I'm just actually going to close this and take a look at a few other things here. All right, so unfortunately, this is the end of the video, but just to touch on a few things that I did do. I took a look at a few things as far as suspicious ARP poisoning activity. Took a look into that, and you get to see a few different things. You get to see like the real-time status and how different groups can be displayed within this particular application with the changed MAC addresses, which is retrieved from the ARP cache to determine if the poisoning or not, right? But nonetheless, this is the end of the video. Unfortunately, I wish I could show more than what I did show in this video. I apologize if the recording was a bit, mixed up, but that has been, or this has been, identifying indicators of a network attack. Next, we'll be going over network assessment tools. I'll see you there.